All right, so continuing on, there is a way, and that's what we're about to talk about. There is a way to find the coefficients of the binomial expansion with higher exponents, and it works with the lower exponents too. But you certainly need this with the higher exponents if you get up, beyond to the 10th power, for instance. And so it's utilizing what's called the factorial. And so the product of the first n natural numbers is denoted by n with exclamation, and it's called n factorial. And so all it is, like say 5 factorial would be 1 times 2 times 3 times 4 times 5. So you just go up to whatever that number is, multiply that number by all the numbers that come before it. And by definition, 0 factorial is 1. And we could, it is provable that it is 1. So the binomial coefficient, and this is if you've ever taken probability, even kind of basic probability, or looked at counting principles, as far as, how many ways could you select, you have 10 books, how many ways could you select 4 of them, that kind of thing. That's getting into probability. So if you've ever taken probability, you may have seen this. The binomial coefficient. So n is our exponent. R is whatever term we are on. Well, not exactly what term we're on, but what would the a exponent be, I guess, would be a better way to look at that. So if the a exponent is 2 and we're expanding to the 5th power, this would be the a squared term, or the a to the r term. And so it's find, you could say we have n choosing r, but it's going to be the n factorial divided by r factorial, and then the difference between those two factorial. So let's see how this works. There's actually, your calculator may have a command to do this. So that's something you might want to Google. Just Google whatever model calculator you have, and then factorial. And if it can do it, it'll probably come up how to do that. So let's do a couple of these. So 9, choose 4. So this would be 9 factorial over 4 factorial, and then 9 minus 4, which would be 5 factorial. So the denominator numbers always add up to the numerator number. That doesn't mean it equals 1. So how do we do this? There is a shorter way to do this. Rather, you don't have to put in, if your calculator does not have a factorial, and it could possibly have this. So this might be, if you Google how to do this in the calculator, it might be under combinations. So if you want to see if your calculator has this command, Google the calculator model and then combinations, and then maybe it'll come up. But these are not too bad, even if you don't have a factorial and you don't have a combinations button. These are not too bad just to multiply out. But you do not want to just put all these numbers in the calculator like this. So 4 factorial, 4 times 3 times 2 times 1, and then 5 factorial. You don't want to have to do all this multiplication. We can actually cancel a lot of these. So anything that's on the top and bottom, we can cancel out. So generally pick out the biggest, so the bigger of these two numbers on the bottom. And then, so in this case, 5 is the bigger number. So we can mark off all the 5, 4, 3, 2, 1, because those are in the top and bottom. And then you can put these in. That would not be too big of a deal. But you can also, for instance, 3 times 2 is 6. So the 3 and the 2 will cancel with 6. And then 4 will cancel with 8 and leave a 2 on top. So now we're just left with 9 times 2 times 7. And that's all you have to put in the calculator, or 18 times 7. And we get 126. So in this problem, if you had a plus b to the 9th, so that would be your n, and you want the a to the 4th term, it would be 126 a to the fourth, and then the b exponent would be 5 because they have to add up to 9. So if you're looking for that term, that's all you would need to do. 100, choose 3. So this would be 100 factorial over 3 factorial times 97 factorial. So choose the bigger one. So this one is 97 times 96 times 95 times 94 all the way down to 1. And this is 100 times 99 times 98 times 97 times 96 all the way down to 1. So really, these two will cancel, and all you're left with is 100 times 99 times 98. And then the rest, 97 times 96 on down, will cancel with the 97 factorial. And then on bottom, you have 3 times 2 times 1. And we'll just multiply these out. We won't worry about canceling anymore. And we get 161,700. All right. Now this one, this would be 100 factorial over 97 factorial times 3 factorial. And so notice these are the same. And so obviously this will come up to the same answer as part B. So anytime that they mirror each other like this, so 97 plus 3 obviously equals 100, they will be the same. So for instance, pick another 10, choose 4. That would be the same as 10, choose 6. So when this number is the same and these two numbers add up to whatever n is, then they're going to be equal. And so that's also why when you have your triangle up here that we talked about, it is a reflection around that center. So you go down the center and it's symmetric around that. So, and that's why. All right, so let's look at an example. We can get there. So notice, well, before we do an example, notice if n is 5 and we're going up from 0 up to 5 with these, 5 choosing 0. So that would be 5 factorial over 0 factorial times 5 factorial. So those obviously are the same. 0 factorial is 1, so we just get 1. 5 factorial choosing 1 gives us 5. 5 factorial choosing 2 gives us 10, and so on. And so these are precisely the entries in the 6th row where n equals 5. So we start with n equals 0, n equals 1. So n equals 5 would actually be the 6th row. And these correspond perfectly to the coefficients that are showing up on that row. And so that leads us to the binomial theorem. And so the binomial theorem, if we have a plus b to the n, we can use these combination formulas, the factorial formulas, and start off with n choose 0, and then we're just going to increase as we go along till we get up to we have n choose n. And then the a exponent b, first one is a to the n, goes down each time till we get to a to the 0, and then b again starts to b to the 0 and then goes up. The exponent increases every time. So just to do a quick simple example here, x plus y to the 4th. And so we'll use this theorem here. You can use Pascal's triangle if you like, but we're going to use the theorem. So first term will be 4 choose 0, x to the 4th, y to the 0, if you like. The next term will be 4 choose 1, x to the 3rd, y, plus 4 choose 2, x squared, y squared, plus 4 choose 3 xy cubed plus 4, choose 4y to the fourth. All right, so anytime you have a 0 here, that's always going to be a 1. So that's just going to be x to the fourth. 4, choose 1, and you can multiply these out if you want, but I won't do it here. But that's 4 x cubed y. 4, choose 2 will be 6 x squared y squared, and then 4 xy cubed, and then y to the fourth. And so that is what we would expect to get, and it is what we get. And you can double check the math for these: 4 choose 2 being 6, and 4 choose 3 being 4. You can check the math on that if you like. And so let's look at one more example. So the general term. So this is finding a particular term, not finding all the terms. So a to the r, so the term that contains a to the r. So we need to find n, choose r, and then of course we have a to the r, and then b to the n minus r, because these have to add up. Again, the exponents have to add up to n. So if we want to find the term that contains x to the fifth in this expansion, so that would just be 20, choose 5, and then of course a equals 2x, b equals y. And so we'd have 20, choose 5, 2x would be raised to the fifth, and then y would be raised to the 20 minus 5. So 20, choose 5, that'd be 20 factorial over 5 factorial times 15 factorial. We'll do this over here. So you can write this out, but you can stop at 16 because 15 and below will be canceled out with 15 factorial down here. And then here we have 5 times 4 times 3 times 2 times 1. And let's just see what we can cancel out. So 5 and 20, that'll leave a 4 on top. 4 and 16 will leave a 4 there. And then 3 and 18 will leave a 6. And then 2 and 6 will leave a 3. So we have 4 times 19 times 3 times 17 times 4. If you don't like that, you can multiply it all out. It's not a big deal. Although maybe with 20 that might not be wise, but you can do it. So we get 15,504. 2x, so we'll write this down here. And actually, well, 2x to the fifth. So 2 to the fifth is 32. X to the fifth, and then y to the 15th. So we have 15,504 times 32, x to the fifth, y to the 15th. And now we just have to multiply 15,504 times 32, and we get 496,128 x to the fifth, y to the 15th. And so you can see, you can get big numbers. It's very possible to get bigger numbers, especially if the exponent is big, you're going to get bigger numbers. So don't worry about if you get something that seems outrageous. Don't worry about it, because it's very likely that's what you're supposed to get. So, all right. So if you have any questions, feel free to email me.